Hi everyone, welcome back again to our channel, and in this video we will look at the application of Kirchhoff's current law. So with this example we'll try to apply Kirchhoff's current law to solve this circuit. So the question is compute the current through the resistor R3. So we need to find out the current through R3, which is I. Okay, if the voltage source supplies a current of 3 amperes. So this is the voltage source and here is the current source. In the question it's given the supply current is 3 amperes. So let's write it here. Now we need to find out current I. Find out I. So we'll try to solve this problem with the help of two techniques or two methods. So let's first look at with the method 1. So the first thing is find out the available or the number of nodes present in the circuit. So as we defined in the very first lecture of the network theory playlist series, that node is a point where two or more branches meet. So we can see here, if you let's walk through the from the supply towards this. So you can see here there is point where this one, this and this three branches are there. So this is node A, and this is this another node, let's say B, where three branches are there. So minimum a node is defined where two or more branches meet. So here you can see another node, let's name it as C and D. So branch B1, B2 and B3. So we'll apply the nodal analysis or the Kirchhoff's current law in this circuit. So here the current is 3 amp. So through the R1 it will be 3 itself. Now if I apply the KCL at node A, so 3 ampere is going towards the node A and 2 amperes, which is given in the circuit, is going out of the node. So let's say, so whatever 3 was coming and 2 is going. So I can say 3, and let's say the current through this is I2. Okay, so I2 is going out and 2 is going out. 3 is entering the node. So 3 must be equal to 2 plus I2. So that means I2 equals 3 minus 2, which is 1 ampere. Or you can also say 3 was going towards this line. Out of that 2 went down. It means 1 is going towards the node B. So 1 ampere is the current here. Now 1 ampere is entering the node and the current I is exiting the node. So, and you can also see that the 5 ampere is passing through this path, which is here. So 5 ampere is entering the node, 1 ampere is also entering the node, and I is the current which is exiting the node B. So if I apply the KCL at node B, KCL at node B, that will give us 5 plus 1 equals I, right? And that is the current which has been asked in the question. So the current I equals 6 ampere. So 6 ampere is the current passing through node B towards D. Okay, so the current passing through the resistor R3 is nothing but 6 amperes. So another technique, let's look at another technique, method 2, where so 3 ampere is passing in this through the power supply. So the current in this branch would be 3. So the current here also would be 3 ampere itself. And since the path is same, so current in this path is 2. So let's say the current from D towards C is, or let's say the current going this side is I4. So if I apply the KCL at this node C, so I can write here KCL at node C. It would be the I4 is exiting the node. So let's first write the current entering the node. So current entering the node is 2, which is equal to current exiting the node, which is nothing but here 3 amperes. So 3 plus I4 is also exiting, so I4. So in this way I4 would be nothing but 2 minus 3, which is minus 1. It means the direction which we assumed I4 is opposite to the actual direction. So thereby instead of I4 will not go in this direction, so the actual direction is this way, means this is 1 ampere. Now we know the current here, and since this path is same, the 5 ampere is the current in this branch. Thereby 1 is exiting the node and 5 ampere is also exiting the node D. So now if we apply the KCL at node D, KCL at node D, right? So that would be the 5 entering the node is current I, and exiting the current exiting the node D is nothing but 1 plus 5, which is equal to 6 amperes. So in either method, we got the 6 amperes of current through the resistor R3. So this is one of the finest example of Kirchhoff's current law. So thank you for watching the video. Stay connected. Hope you found this video insightful. In the next video, we'll try to look at another problem where we can see the application of Kirchhoff's current law. Have a nice day. Thank you.